1, 2, 3, 4, 5. Hello, hello. 1, 2, 3, 4, 5.
Accetti un montaż wideo?
Tak je to, tak je to.
Ty jsi protože pán režisér.
No nevím, jestli režisér, ale chyták jsem to tady tu
Keď budu někoho potřebovat,
určitě.
Budu někoho trebat, tak budeš to ty jako, hej.
Ano, ty na dálku.
Skurvil video. Dáte to potom na YouTube, jo?
A to se rokově vysílá na YouTube. Dobře.
Vieš, že Pavla Zubinu mal zdravotné problémy. Bol jsem za ním.
Jo. Já už totiž nejsem v kázetě, víš, tak jak jsem se viděl.
Já jsem byl na jedné bezpečnostní konferenci.
Tak to se není musí zastavit.
Walters are already looking at
Did you saw Charlie?
Yeah, he's here. I watched his presentation.
Yeah, okay. I have also stick. Must look for. Maybe you can put it in and then I can show you.
Let me finish this.
So you are the cameraman.
Yeah.
Whose shake is that?
My check.
Your shake.
Yep.
Crowded.
Oh,
Crowded looks.
little bit.
So clean checks are nothing.
Right,
Only for demonstration.
right.
I can do it also.
So I will do. Let's go. Prosím? Byla to? Jo? Let's get the workshop here. Let's get the workshop here. 47 giga. Okay.
Different version.
Okay. Which one?
Workshop.
What's that? And yours. My 47 giga, but where I have it. Jesus Christ. Wow. I have it on my USB. I have to find where I have the monitor. It's not here. No, this is for control. Yes, this one is there.
Nice to meet you again. Absolutely.
So, who will start? We will have a microphone.
1, 2, 3, 4, 5.
You will have a second one. But I think that one will be enough.
Now, what if I wanted to show some demonstration that can we access the projector?
Sure.
Sure. So it could be done from here.
Sure. Internet up there.
Well, I'm afraid it's just like the screen.
Exactly.
Okay. The other question is, do you
Maybe yes. Maybe yes. Maybe yes. I have to check my login. I'm going first for my mistake with the presentation. Okay? If you want, you can start. Or if you don't like for me, it depends on you. Okay. Give me 1 minute. All good. You can go there because everything is on your own.
So very good. Hello, is working.
So very good. Manfred, please be careful. We are not young anymore. So very good evening again. I am so happy that I see so many faces, and I'm expecting that half of them will start at 47 gigs soon. And before you will start to do this in the most crazy ham radio band for moon bouncing, we have prepared for you the workshop which start Charlie and will follow Manfred, and on the end I have a couple of the information about I am thinking and what I have recognized with the moon bouncing and receiving signal via the moon on 47 gigs. So the Charlie, this microphone is yours, please.
Thank you, Zdenek, and very nice to see so many people here this evening. This was originally planned to be a WSJTX workshop, but we've been working together very closely with the 47 gigahertz group and making some changes to WSJTX, which we think have helped the progress. A few technical changes, and I'd like to show you some of these. Some of this will refer to my talk tomorrow. Much more information on many of these topics is in the presentation on the memory stick. So, 47 gigahertz and WSJTX. So the first thing that we looked at was what is the best submode and Doppler tracking method for 47. The problem with and 24 is a very similar point. The problem was that when WSJTX was originally released by the development group, there was discussion about an option for an even wider tone spacing submode, but that has not been possible. So we've looked a lot at Q6560E as the only sensible mode to use on 47. The other thing that is very new is a brand new echo mode that Joe has written. It's still in development. It's in WSJT 2.6.0 RC2, release candidate 2, which is downloadable now. But it is changing as we go on. He's on holiday at the moment, but when he gets back, we expect to see a few more iterations, we hope, of it. One of the features that is not generally needed for the echo mode is this fspread.text option, and I'll talk a little bit about that. That's something that we've refined or has been refined to make ultra weak signal detection possible. And this is what we are using in the echo mode, the monitor option. Now, this is not you receiving your own echoes. This is you listening to another station transmitting even a 5-minute solid transmission. Now, some gentlemen have got a fantastic stable transmitter that can run for 5 minutes. So Manfred here has been acting as a beacon for people to listen to. And we started with single carriers because these are easier to detect than getting a decode from the Q65 60E transmission. Now moving on to using the program to actually make contacts, obviously it has been done. A single message has been decoded on 47, but a lot of the time you're going to need averaging, where it accumulates multiple messages of the same content to achieve a decode. The other thing that has been found, I think this is EBAM's finding, is that the FTOL parameter, you'd think with a very widespread signal you could use anything, but it turns out that a very narrow FTOL setting can sometimes get a decode when you can't get one with a more normal FTOL of, say, 100 Hertz. And the other final point is signal reports are quite difficult to get accurate with Q6560E.
se objevil nějaký dotaz, dáš nám vědět?
And you may see a decode at -14 and think, oh, I've got
To nevadí, to bude potom ke stažení na webu, ale teď je potřeba, aby slyšel, o čem se mluví, rozumím. Karno to kašlí.
But it reports, and possibly to do with the very wide spreading, the signal reports that are being reported look too good. Doesn't matter, you make the QSO, what the signal report is, provided you receive what the other station sent, is all good. So why Q6560E? Well, early on, we did some simulations of 3 possible modes to use. It was 60E, the lower tone spacing 60D, and 120E. Now, the interesting 120E is because it's you have a 2-minute period. So in 2 minutes, you're effectively collecting twice as much energy as you are in 1 minute. So a simple understanding would be that you could gain 3 dB by transmitting for twice as long. It isn't as good as that, but it is certainly well over 2.5 dB when conditions are right. The problem is that when the spreading gets high, the tones start to interfere with each other. So you do not get the full advantage. Down at low spreading, then you can get down to say -29 dB and get a decode. But at 500 Hertz spreading, and that's low for 47, I mean normally it's up here somewhere, then the 120E is not worth using. So everything now is Q6560E. It's fine, but in my other talk tomorrow, I'll be talking about how to make sure your system can work well with 60E. There are a few pitfalls which can result in it not working as good as it should. It doesn't really matter too much what Doppler correction mode you use, but constant frequency on Moon has the big advantage that everybody knows what frequency you're going to be on. You can have several stations listening, and the Doppler correction is all very straightforward. So, strong recommendation to keep using that. The other thing that we've been making the point is the program, if it knows the call sign of the person being called, it is very good to set that up before you start to listen, because the EP, the prior knowledge operation of the decoder, means you can gain up to 4 dB of sensitivity. So you should always never call CQ and expect a random caller to come back. You won't decode it on 47. So it's SCEDS and it's entering the call sign before you start. The other thing is we strongly recommend the use of the reference spectrum. Not that many stations use it. I'll be talking about it some more tomorrow, but it has the advantage of flattening the audio passband, which can make decoding better on very widespread signals. So a little bit about the echo mode used in monitor. So the early test on 47 were with Manfred transmitting and other stations trying to receive him. At that time, nobody was getting any decodes, but it was important to know, was the signal actually getting out, and also what level was it, because we didn't know exactly what sort of signal to noise to expect. So the new echo mode, when monitoring the other station, this is 5 minutes, and you can see for over 3 minutes, it wasn't detecting anything. But once the averaging starts to build a clean spectrum, then it's able to determine, if you like, locks into the signal and in this case, it was running at about -30. We did test it with just noise, to prove that the thing is actually really detecting the signal, and that's the sort of plot you get if there's no signal there. So it's giving this absolutely genuine detection of the signal. And this is probably 5 dB, 6 dB below what the Q65 could decode. So for testing one station to another, in early tests, you strongly recommend the use of the monitor mode in WSJTX as being a way of being sure that you're copying something, and also being able to measure the level. The program gives a printout here, and you can see Joe has calculated the error in the report. So it's -28.6 SNR, and with an error of 3.3 dB. So it could be, 3 dB up or down on that, but this is still a pretty good measurement of a very weak, widespread signal. Far better than you can see with, for example, the linear average plot of WSJTX. Now, I'm not going to go through this now, but it's in the presentation. This is how you can set up this fspread.txt file. Reason you do that is that if you don't, WSJTX uses the spreading it calculates at the time. So it knows the DX station, it knows your location, it calculates the Doppler spread, and in some cases that might be 700 or 800 hertz. And it will feed that into the detector. But we found that if you can limit the bandwidth artificially, and this was actually a facility that Joe built into the program for testing, is you can not fool the program, but you can tell the program to use a specific value of spreading. And we found 400 hertz is about the best you can choose to get the best detection of a very weak signal. So for the purposes of testing, you have to create this text file, put it in the right place, and do remember when you finish to remove it, or every test you do will be at 400 hertz spreading, because it takes preference from this file. But it is a useful tool